Hi. This instructional video is about a rate problem. So car A is leaving Los Angeles to go to Las Vegas at 65 miles per hour, and the total distance is 260 miles. Car B is going back home to Los Angeles. Won the jackpot, I guess. She's so happy. She wants to get home and share the money that she won from the jackpot. And they're driving at 80 miles per hour. And the question is, at which point, taking the same freeway, I think they're taking the Highway 15, Interstate 15. Where would they meet? Which mile marker? Visually, this car's going slow, this going faster, so they're not going to meet in the middle given the same time. They will probably be somewhere on the left side of the midpoint. But where? Go ahead and try that. All right. So, when it comes to Common Core mathematics, they're always emphasizing solving problems and showing it three different ways. It's to do it numerically, and to do it graphically, and most important, analytically. So they want you to do it three different ways, and from it, they want you to be able to narrate or elaborate and rationalize what the problem and the solutions mean. That's the whole premise of the Common Core. Not just crunch numbers, but to actually think about it in a deep and profound ways. So here's what some of the kids did, and they were pretty correct and clever. They just weren't able to verbalize it or rationalize it. They did it numerically because that's all they knew how to do. Here's what they did. They took the average of the two cars and divided it by the total miles for the rate. So for example, car A is at 65 miles per hour. Plus the car B coming back is 80 miles per hour. Now we don't care about the velocity, the direction that is. It's just a speed. So they're taking the average of the two speeds. So 65 plus 80 is 145 divided by 2. So the average speed, whether they're going in one same direction or in opposite directions or diverging, it really doesn't matter, it turned out to be 72.5. But now they're going to direct that going in opposite direction of each other. And to find the average time for the both cars, what they did was take the distance 260 divided by 72.5. And 260 divided by 72.5 is 3.586. So maybe we could just call it 3.59, round it up. So about 3.59 hours for the both cars. But now, of course, there's two cars, so we have to divide that by 2. So take those two cars and divide it by 2. And it turned out to be 1.793, so round it to 2 decimal places. So it was about 1.79 hours. Okay, given the same time. So it would take 1.79 hours to meet somewhere, to intersect each other, that is. Okay? So when the question was, well, if it takes 1.79 hours to intersect each other, where would they be? So all they did was just take the rate of one car. So 65 miles per hour times 1.79 hours. So the hours cancel out. So therefore, 1.79 times 65 miles per hour for car A turned out to be 116.55. 116.55 miles. 116.55 miles from Los Angeles. The midpoint between the 260 is actually 130, is it not? That's the midpoint. Maybe that'll be the Death Valley somewhere. Okay? So 116 is about over here somewhere, they're saying, at 116.55. Okay, that's the point of intersection. That's pretty clever. So maybe they meet at the gas station. Hey, how'd it go? Oh, I made it big. Oh, you lucky you. All right, well, good luck to you. Thanks. And hopefully. So that's how they did it numerically. But how do you do this graphically and analytically?